Here in this video, we will do an example of a t-test or a confidence interval for the mean using a t-distribution. So I'm getting my inspiration from the original 1908 paper, not the original, there was stuff done before that, but the one that everyone refers to, which introduced the t-distribution in this technique. So this guy, William Gossett, worked for the Guinness Brewery in Ireland making Guinness beer, and he was measuring the chemical properties of barley grains they were using in brewing the beer. So let's suppose we're studying the protein percentage in 3 samples of barley. So we get the first one is 11.3, and the next one is 11.7, and the final one is, say, 13.2. All right, so we have to ask, are these approximately normally distributed? We have to verify this for our... So we can plot our data points on the line, see where they showed up. So we have 11.3 lands about right here, 11.7 right about here on the plot, and 13.2 lands over here. So with these, it's not really obvious, like this one maybe is an outlier, maybe not. For our class, we'll say that this is not, I do not consider this to be too much of an outlier. It'll be more extreme, and I will make it clear. So here's the problem statement, and that's construct a 98% confidence interval for the mean protein percentage. So we have 3 observations. We'd like to get an interval for the mean. So I'll write the formula as this. We have x bar, the sample mean, plus or minus some t multiplier. I haven't said what it should be yet, so we'll work that out. And times the sample standard deviation divided by square root of n. So let's write down what all these are. I'm lazy with the calculations. I want to do them as quickly and accurately as possible, so I'm just going to do them in R. So I'll copy and paste what I have here. So this is how you would do this inside of R. Rather than actually computing the mean using the formula, you can just call the function mean after you define x in this way. So x is equal to c, function concatenate or combine on 11.3, 11.7, and 13.2. You get the mean, and it is 12.07. Similarly, you get the standard deviation. And the standard deviation is just SD of x. So you can plug that in. You can verify that this is the same as the formula inside your book. It is. So S equals 1.002 approximately, rounding it. Got lucky. Then our T multiplier. So we're looking at T mul. We need to find the 1 minus alpha over 2 quantile. T multiplier is 1 minus alpha over 2 quantile for a T distribution with 3 minus 1 equals 2 degrees of freedom. So here, alpha is equal to 100 minus 98 divided by 100, which equals 0.02. So alpha over 2 is equal to 0.01. And then 1 minus alpha over 2 is equal to 0.99. So we're looking for this quantile. We can use a t-table with 2 degrees of freedom. We can also use R. If we're using R, we write this code. QT here. So Q for the quantile, T for the T distribution. We're looking for the 0.99 quantile that we determined right there. The degrees of freedom is 2. 3 minus 1 is 2. And we get this number out. 6 point, so T mul, this shows that T multiplier here should be equal to 6.96. So you can find this from the table or from R, like as we've shown. That's the one that we're interested in. Now we can construct our confidence interval, plugging it into this formula. So plugging it in one step at a time, x bar was equal to 12.07 plus or minus. T multiplier is equal to 6.96. S equals 1.002. N equals 3. Okay. So I could type all those numbers out in R into a calculator, but since I've saved them all into variables like T-mul that we have here, and this S and X bar, I can use all of those, which are already defined, and just kind of plug in my equation. So then it would look like this in R, where I'm just literally plugging it into the formula. I'm writing the formula out in R. And then I get my upper bound of 16.09, my lower bound of 8.04, and the upper 16.09. So this is the answer. This is my 98% confidence level. Confidence interval for the mean, rather. But if you have the data and you want to be really quick about it, figure it's worth showing you just so you know. All this stuff is built in. This is very standard statistics stuff. So you can just do it in R. So there's a function for it. T-test is the function. Confidence level equals 0.98. So it's exactly this. We had our data is in X. Remember that we entered X right up here. So here's where we defined what X is. So if you have your data in a variable in R already, then it's really easy to do this kind of thing. And we go over here, we find a 98% confidence interval, and it just prints it out for us. It's 8.04 to 16.09, which, whoa, lo and behold, it's the same thing that we calculated here. So that means we did it all right, and we're all good. Again, I'm not suggesting that you do this for the exams. There might be some questions where you can get away with doing this, but you'll need to know how to use the formula, because I might not give you the data itself. One other thing, a couple interesting things just to mention about the T distribution while we're talking about it, is that a T distribution with degrees of freedom 1 doesn't have a mean value. The mean is undefined for a T distribution because it's so spread out. So the expectation is given by the mean is the integral from negative infinity to positive infinity of x, f of x dx. This integral is not defined for a t distribution of degrees of freedom 1. So a mean doesn't necessarily exist, and the same is true of the variance. It doesn't exist either. So it's kind of a strangely behaved distribution, even though it has a clear center point, it has a clear median, it's 0, just like it would be for the normal distribution. So just some fun facts about the t distribution.